In this part, we will discuss about ELISA test or ELISA technology. It is basically one test which detects different type of antigens present in the serum or any other fluid. So first let us write what ELISA stands for, okay? Let us write ELISA. E stands for enzyme, L stands for linked, I stands for immuno, S stands for sorbent, and A stands for assay. So ELISA stands for enzyme linked immuno sorbent assay. So first let us say in this way that what is ELISA test? ELISA is one type of assay test. What it is? Assay test. What is assay? Assay, this word sounds like as, but it is not related to any type of as. Assay is actually one type of investigative procedure which is used in laboratory, in case of medicine, in pharmacy, in pharmacology, in environmental biology, in molecular biology. In all these fields, assay test or assay system is used to detect a target entity. A target entity is being detected or investigated by assay techniques. What I have said, let us explain it with an example. For example, there is a person, okay? There is a person, write down there is a person. There is a person. You were suspecting that in that person there is HIV virus. So if that person is infected with HIV virus, in that person's serum, obviously there will be antigen of HIV virus. So what we are suspecting here? We are suspecting here HIV. HIV virus antigen is suspecting here in that person. So first, let's take the serum from this person's body. Take out serum. Okay. Now, what is assay actually? In assay technique, suppose this is the serum. This is the serum, and what is our target entity? Our target entity is actually HIV antigen. HIV antigen is our target entity. In assay technique, assay will help us to know whether the HIV antigen is present there or not. First of all, it will give us information about the presence or not, about the presence or absence. Okay. So if it is confirmed that HIV antigen is present in that serum, then assay technique will also give us the qualitative and quantitative information too of that particular antigen. It will also give us, it will also tell us that in how much concentration that particular antigen is present there. So quantitative and qualitative, which type of antigen is present there, that will be also, that information also can be got from assay. So ELISA is basically one type of assay, and it is not a simple assay, it is one immunosorbent assay. In this assay system, we will use immunosorbent. What is sorbent actually? Sorbent is nothing, for doing any test, there you need some reagents or you need a medium. So sorbent is one type of material which is linked to adsorption. Okay, adsorption means sticking to the surface. Suppose this is a cloth. If it sticks here, this is called adsorption. Sticking in the surface of something. Chipkana, which is chipkana. It is called adsorption. Okay. So sorbent is nothing but a material. Ye sorbent can help other molecule to adsorb, but it has also its own property to be absorbed, So this material is used to absorb and also it absorb different type of molecule. So sorbent is one type of material which is basically linked to the adsorbent property. So in ELISA we will use or we will do one type of assay where sorbent will be used, and that sorbent will not be normal sorbent. The main substrate or one of the important substrate of that sorbent which will be used in ELISA will be some molecules which is related to immunology, the immune system of our body. And you all know the two important molecule which is linked to immune system of our body or immunology, those are antigen and antibody. So this immuno word indicates us their antibody or antigen will be used. And also one thing, and that antibody or antigen which will be used, that will not be a free antigen or antibody, okay? That antigen or antibody will be covalently linked to different type of enzymes. So this is basically the ELISA, word by word meaning. So what is ELISA? ELISA is one type of assay. In this assay we actually do, this is actually one type of immuno assay where sorbent will be used, and in that immunosorbent enzyme will be linked. This ELISA technology was actually invented by two group of scientists. One group was from Sweden. It was invented in 1971, okay? Two scientists from Sweden. One was Peter Parman and Eva Engvall. These two were from Sweden. Two other scientists from Netherlands, they also separately discovered this procedure. They also invented this procedure. Two were from Netherlands also. Netherlands. One is Anton Soer and another one is Bocke von Wieden. So these four scientists separately, these two jointly and these two scientists separately, this four man actually is credited for the development of the ELISA technique. Before ELISA technique, there was also some immunoassay technologies available in the market, but those were not enzyme linked. Before ELISA, there was available radio immunoassay. What was available there? Radio immunoassay. Okay. What was available? Radio immunoassay. So ELISA replaced this radio immunoassay. And ELISA is a more developed procedure. Let us see how ELISA works. It is basically dependent on antigen antibody reaction. So let us see how ELISA. Let us now discuss the detailed procedure of ELISA test. ELISA test is different types. There is basically three types. One is direct test, one is indirect test, and another one is sandwich test. So ELISA test is basically three types. One is direct, one is indirect, and another one is sandwich type of test. We will discuss only direct ELISA test as per our syllabus. So let us now see how ELISA test is being done. Suppose this is a person and we are suspecting that within this person's body HIV antigen is present. Means this person is affected by HIV. So first of all, what we will do? We will take out its serum. If HIV is present in this patient's body, then obviously the antigen HIV will be present in the serum. Remember, here actually we are going to test for antigen, and not only HIV antigen will be present in the serum, a lot type of enzyme will be present. For example, you say there is A antigen in the serum, B antigen, C antigen, D antigen, okay? And for example, you take that this B antigen is for HIV. This B antigen is for HIV. So we are looking for this B antigen. So first what we will do, there is a ELISA plate, ELISA test plate. This ELISA test plate is basically made up of plastics, and it is made up of polystyrene. Okay? At the first step, what we have to do, we have to depot the serum here, pour the whole serum or depot this serum here. If you give the serum, this ELISA plate is made up of polystyrene, and what type of medium is used here? Sorbent is used here. Different, you know, I have told you earlier that sorbent is basically helps in adsorption. So if you depot this serum here, all these antibodies will stick to the surface. For example, A, B, C, D. These antibodies are stick with the surface. Okay, these antibodies have an affinity to stick with the surface, and this affinity has been facilitated by the help of sorbent. So these are added here: A antigen, B antigen, C antigen, and D antigen. Okay, we're looking for B antigen. Okay, we're looking for B antigen. In the laboratory, we must have also reagents. What reagent we should have? Let us see. In the laboratory, what should we have? In the laboratory, we should have preformed. Remember the word preformed antibody. As we are testing or looking for antigen, then we have to use its counterpart antibody. Okay. So in the laboratory reagent, there is preformed antibody. So what antibody we will use? As we are looking for antigen B, so there will be anti-B antibody will be there. Anti-B antibody is needed, and this antibody, you know, this antibody is not alone here. See the name, enzyme linked. This antibody is also linked with one enzyme, and this linkage is covalent linkage. Okay. So in the laboratory reagent, you must have antibody and enzyme linked antibody. This antibody, this is antibody's FC site, FC arm, and this enzyme will be attached to each other by covalent bond. This is preformed. Now what we have to do? We have to pour this reagent here, but before pouring this, before depositing this reagent into this plate, we have to do two important procedures. What do we have to do? First, before, so we're not giving it right now. First, we have to use some special chemical, some special blocking agent we have to use, which will block all the surfaces of the polystyrene ELISA plate where antigen is not attached. Okay. So we will use blocking agent. What is blocking agent? Blocking agent is one type of chemical. It will block all the places, all the surfaces of this polystyrene plate of ELISA. So now if we depot the reagent here, a reaction is possible only here, and here. In this place, as these are blocked by chemicals, so no reaction will be possible. So after adding the blocker, we have to wash out. the solution. We have to wash it. Why should we wash? Because there may be a lot of antigen which are not sticked, or there may be a lot of blocking agents also which are not sticked in the surface. They may be floating. So we will wash it out. Okay, we will wash it out. So first we have given the antigens. They have stick to the surface. Then we will add some blocking agents. Then we will wash it out. After that, after washing it, what we will do? We will give this reagent back. What is in this reagent? In this reagent, there is anti-B antibody linked with an enzyme. So let us draw this. This is the anti-B antibody. Okay, this is anti-B antibody, and this anti-B antibody is linked with an enzyme, and this enzyme have one special capability. Not any simple unanonymous enzyme is added there. This enzyme is actually one marker which will help us whether there is the antigen present or not. This enzyme has special capacity of transforming colorless substrate to colorful substrate. So this enzyme has one special capacity, one special capability. What is the capability? That it will convert colorless substrate to colorful substrate. Okay. So the mostly which type of enzyme is used? The mostly used enzyme in ELISA is alkaline phosphatase. Alkaline phosphatase, beta D galactosidase, beta D galactosidase. This type of enzyme is generally used, and if you use alkaline phosphatase, then one special colorless substrate has to be also used. And here, if you use alkaline phosphatase, then the substrate will be PNPP. PNPP will be the substrate. Okay. So what we have already done? We have deposited that serum into the plate. We have blocked all the surfaces. We have washed it out. Now we are adding this reagent which is containing anti-B antibody linked with one enzyme. For example, say alkaline phosphatase. So this antibodies, as it is anti-B, will bound only to B antigen. It will not bound here. Okay, it will not bind here. It will not bind here, or it will not bind to here. It will not bind to here. It will not bind to here. It will bind only to B antigen, as it is anti-B antibody. Now what do we have to do? We have to wash it out again wash, because there is a lot of antibody which is not attached to any type of antigens. So after washing it, what you will get? What you will get? You will get only this. Only antigen and antibody product, the antigen antibody collaboration, antibody antigen attachment will be in B antigen. If B is present, if B is not present, then there will be no attachment. Every antibody will be washed out. Now add that substrate, this colorless substrate. Now add substrate, colorless substrate. This colorless substrate, if the antigen antibody, this complex has been formed, then obviously this colorless substrate will form some colorful substrates. After adding that substrate, if we find that the color has been changed or the color has been produced, then we will be confirmed that antigen is present there. Even we can also take idea about how much concentration the antigen is present there by looking the strength, by looking the amount of color which is produced there. So this is actually ELISA test.